Okay, so I think I finally, like last night, I just stared at it and I think I figured it out. So I like drew a couple of these things to like explain it because I'm like, I think I got it. So, for part A, like I did each part to make sure like they each made sense and like I did all like the calculations to make sure the ranges were right. Um, so I think what's going on is I when I was talking about it with you last night, I was saying like, oh, like no matter like if for example here, like if R1 is like a certain resistance, there's always going to be like the same amount of voltage drop right here, so why would it matter what R2 is, you know? I was forgetting that like current is part of the equation for that. So like the voltage drop across a resistor is dependent on the current going through it, and the current going through like the whole circuit is dependent on both of the resistors that you're putting in, like not just the resistance and the voltage. And that is like the main thing that I was confused on. So after that, like it just kind of solved itself. So I'll go through it, and it's like good for me to explain it too, and just like make sure I understand it, and hopefully like it'll help you too. So for like part A, I think what's going on is so you had your potentiometer as your R1, and R2 was just like your constant resistor, and then your load was it was parallel to like this stuff, and it was connected to like this third terminal, which is like the variable output. And so I did the ranges on this page. So R1 went from 0 to 10K, and so at 0 ohms, I said like the 0 position was all the way at the top because there's no resistance between like these 2 points. So at 0 resistance, it just looks like this. And like just like to like logic check it, like it should just drop 9 volts because V2 is like these 2 points here, which is the same as these 2 points here. And if 9 volts is coming out of here, then it should be like 9 volts up here, and it should just drop all of its stuff at the bottom. And one thing like really important about voltage dividers is that they don't like, it's what we were doing in the lab. They don't work if your load resistance is too high, because the idea is like these equations are literally just Ohm's law like rearranged, and it's like saying that our like the load resistance is small enough that you can pretend these are in series, and so that's like it'll probably be a little confusing to look at this and say like there's like, oh, there's like no voltage drop across this resistor. It's just because this resistor is like so small that oh wait, maybe it's large. Maybe it's that this resistor is so, okay, I probably just really confused you, but the concept is the same. I'm sorry. So I think RL is actually supposed to be really large. And I think, yes, because you remember in lab, we were talking about, I'm so sorry, that was probably so confusing. Okay, well, oh well. So do you remember in lab when it was like the like 100 ohm resistor, it would drop and it would be like something in like the millivolt range, and it was really small. And then when we measured it with like the 100K ohm resistor, like it was almost like if you had 5 volts between here and here without a load, then it was like almost 5 volts with a really high resistance. Okay, it's because of that. I was just like not thinking. It's because it's in parallel. So if you have a really high resistance here, then not very much current is going to want to go through there. And it's all just want to go down here, and it'll act like these are in series, like this, for example. Okay, so back to like the potentiometer and how it works. So at 0 ohms, I said like the potentiometer was always at the top. And so it would look like this, where it's just like both these resistors in parallel with the load line. And that would just be like the 9 volts. And that is what I got. So I did this calculation off to the side. You can see it if you want. And this is what we got in lab. We found that if we like put the potentiometer all the way to one side, then it would be 9 volts. And then at 10 kilo ohms, it's all the way at the bottom. And so it would be like coming out here, there would be one resistor, and then there'd be like this parallel load thing going on. And I did the calculations. I got 1.5 volts, so it's correct and everything. And again, that's just like it like varies depending on like your value for R2. And that's just because like the current will vary if you make this like bigger or smaller. So when you have like 10K ohms right here, that is much, much higher than like 2K ohms. So there's going to be a much higher voltage drop on a higher resistor than there will be down here. So this will drop from like 9 volts to like 1.5 up here, and then it'll drop from 1.5 to ground down there. So that's that idea. And then in part B, the potentiometer was the second resistor. So you always have, R1 is always at the top. And this is probably a little confusing, and I was stuck on it for a while this morning, like looking at it. But what it is I said like it's the same, like the 0 position is all the way at the top of the potentiometer, and the 10K position is all the way at the bottom. It's the same up here, but it just behaves oppositely. So I like did all the calculations, but you just have to like swap them in your head, because like, yeah, like the 0 ohm position acts like a 10K ohm in this case, just because of like the way it's positioned. So here what it's doing is yeah, so at the 0 ohm position you have like your first resistor right here, and I think in this case we chose R1 equals 8K, right? So 8 kilo ohms and 10 kilo ohms down there. So this is going to drop, we want it to, when it's at 10K, we wanted it to drop 5 volts. And it should, because that's like 10K and 8K are like almost even, and 9, like minus 5 is 4. So that's like about even, so that sounds right. So so you'd have like 9 volts coming out of here. It would drop 4 volts right there at this 8 kilo ohm resistor, and then it would drop 5 volts. Yeah, 5 volts right there, because that's a 10K resistor. And again, because the load is ideally really high on that resistor, not very much current is going to go through it. And most of the current is going to go through here, which lets you act, like it lets you pretend like that's in series. So hopefully that makes a little bit of sense. And again, just like it's a little confusing, just remember that V2, we're measuring at these nodes right here, or these nodes. It's like just, it's the difference between ground, so 0 volts, and whatever happens after it goes through that first resistor. So yeah, again, in this case, 8K, it dropped 4 volts, and 10K, it dropped 5 volts. And that sounds right, because those are real close together. And then over here, when it's at the 10K position, but it's acting like 0 ohms, you get, because there's nothing in parallel with the load, so it basically just, like, you have, because the load is really large, remember, so this is going to short circuit it. So it goes like 9 volts through here, it'll drop a certain amount, and then it'll drop the rest. And that is shown right here. So it would be between here and ground, it would be 0 volts, because it's already dropped all its voltage by the time it gets to this node. And then part C was just one potentiometer. And I drew this like equivalent circuit. So if you just have it at like one like arbitrary position and you don't move it, then it acts like 2 resistors right here with your load circuit right there. And then it's the same thing, you just do the math. So when it's all the way at the top, this is just like a regular parallel circuit. And so between here and here, it should be like the full 9 volts, and it is. And then right here, it's a 10K resistor, and basically ground, because you kind of ignore that. And it's 0 volts between here and here. So yeah, you get the whole 9 volt range, which is exactly what we got in lab, which is perfect. And then here, I was kind of confused about like what happened. I wanted to make sure, like when it was in the middle, that like it was behaving like we saw in lab. So I did, I made this little like arrow thingy. So so this is your potentiometer, and you can like, this is literally what it does. It just like scrolls along this resistor. So when it's at like the very topmost like 0 ohm position, there is no resistance between the like VCC, like your battery, and your load wire. So the voltage difference between here and here is 9 volts, because like here and here is the same as here and here. So yeah, that's like a 9 to 0 volts difference is 9 volts. And then when it's at that second position down here, I said, yeah, there's like a small resistance here and a large resistance here. So what the current is gonna do is it's gonna go, it's gonna, like the current, when you change the potentiometer, you change the current. And so there's gonna be a small drop here and a large drop here in voltage. And so I said, yeah, small voltage drop. V2 is a little less than 9 volts. And this would be like in lab when we'd like twist it just a little bit, and it would be like, instead of like 9 volts, it would be like 8.6 or something. So that's because it's the voltage difference between like here and here now. And then, yeah, the larger resistance is parallel. So this resistance is parallel to RL, which is where the rest of the voltage drops. That's right. So then position C, yeah, position C, the resistance between R sub L and VCC is, yeah, it's about even. So we'll say this is like roughly equal to this, which is like, that's kind of like what we saw over here when we split it like roughly in half. Where was that? Yeah, where like this top one was 8K and this bottom one was 10K. Like it's roughly even. It's about the same like over here. So what'll happen is it drops across both sections like about equally. Maybe like about 4 volts will drop here, which means 5 volts will drop here. So your V2 is going to equal like 5 volts in that case. And then position D, let's see. Yeah, position D, there's a large resistance now. Comparatively, this is much larger than this resistor. Between the power and the load circuit, more voltage drops on the first resistor. So this might be like a drop of like 8 volts, which means it's only going to drop like 1 volt down there. So if, okay, I think the example I used is 1.5. So this would be like, it would drop 7.5 volts here, which means this point and this point, the like voltage between these 2 points is 1.5 volts. And that is what that's what we did in lab basically. So I think the whole like idea that we were probably missing was like, when you change your potentiometer, you literally like change how much resistance is where in your circuit, and you change the current coming out of the battery, which will change how much the voltage drops on each section. So yeah, I think that about explains it. And then probably we're gonna have to include it in the lab report to like make sure you mention like when it was like RL was like 100 ohms. There was like V2 is really messed up. It would be like 0.01 volts or something, just something really small, you remember. And then when it was really large, like 100 kilo ohms, then your V2 was closer to the actual like voltage drop when it was unloaded. So I hope that like clears it up a little. I don't know. I was like, that was probably just a lot, but it helped me to like explain it and to like write all this out. So hopefully it helped you too. I don't know. I'll probably still go to office hours and make sure I'm not like crazy, but yeah.